All right, we just went over the homework and the in-class assignment. We're starting the video now. We're doing new material. I want you to refresh your memory. Are you ready? This is all about confidence intervals. Here's what I want to refresh your memory about. There are 3 confidence intervals we're learning. You ready? You ready? The first one is if you know the population standard deviation of the problem, you're using this equation. It's called the standard deviation known. And the equation, I call it the Z equation. Tell me what slide that's on. I know you guys wrote it down.
2.
No. No, it's not slide 2. There it is, slide 10. There's the Z equation, okay? You ready? Next, the second one. The second one says when the population standard deviation is unknown, I call that the T equation. You guys wrote down T equations on slide what? 13. Thank you. Here we go. No, it's not on 13.
18. I said 18. I said 18.
18. Thank you, 18. There's the T equation. That's the second one. The third one has no standard deviation, and it's called the proportion equation, which is on slide 26. There it is. That's the proportion equation. It has no standard deviation. It happens to also use Z, but it's really a completely different equation because it's using proportion. So now, with that said, look at this. Z, T, proportion. Z, T, proportion. An economist reports 560 out of a sample of 1,200 middle-income American households actively participate in the stock market. Construct a 90% confidence interval. Should we use a Z, a T, or proportion? Which formula? I appreciate you. I appreciate. But I still appreciate you. Right? I appreciate it. I do. It's not T. Z. No, it's not Z. What's left?
Proportion.
Are we recording this? Do you see a standard deviation in this problem? If it is, make it appear. There's no standard deviation. This couldn't be any easier. This is just like taking a quiz. This is the part where you guys are going to blow it. Don't be like everybody else. This is the whole point of this exercise at this moment. You look at this question and you should be able to identify which formula to use. This is the hardest part of confidence intervals. Based on a sample of 100 U.S. consumers, a researcher finds that the average amount spent annually on a debit card is $7,790. That's per year. Assume that the population standard deviation is 4,500. What would be the 99% interval? Z, T, or proportion?
Z.
Oh my God, we're back in the game. All right, okay. But still, Monica gets credit for being brave on that first one. You're welcome. Ready? According to a survey, 44% of adults admit to keeping money secrets from their partner. Suppose the survey is based on 1,000 respondents. Compute a 90% confidence interval. Z, T, or proportion? Oh. Yes. What was? Did you say? Wait, was that you already said the wrong one? You only had one left, and you had it wrong again. Is that what you're saying?
Yeah.
Okay. So why was it proportion though? Why? What is it about that last one right there that makes it a proportion? Say it again. That's right. There's no standard deviation. Do you see it? Now I'm asking for this is the thing. You read the question. It's asking for a confidence interval, and either it has the population standard deviation, the sample standard deviation, which means it doesn't have the population, or no standard deviation. This is it. This is how you tell the difference. You get one last chance here. Are you ready? Everybody gets this right. According to a survey, high school girls average 100 text messages daily. Assume that the survey was based on a random sample of 36 high school girls, and the sample standard deviation is 10 text messages. Calculated 99% confidence interval. Z, T, or proportion?
Z.
T it is. T it is because it said the sample standard deviation is 10 text messages. That's what gave it away. All right, you are now prepared for the quiz. We're taking it this Saturday during the game.
That is my birthday.
Stop.
Yeah.
All right, week 2, here we go, we're in week 2. Like usual, if anybody went on Canvas, they should have seen that I put instructions up there like every week. As you can see, there's a written homework assignment, and Excel is included in the written. There's questions on there, you have to do both written and Excel. It's due a week from today, which is Tuesday, September 17th, before 2 p.m., just like last time. There's the materials for today. And I think there's a chance that in week 1's instructions, now the correct pages are on there. I think I had to, after we had our first lecture, I noticed the wrong pages because it was from the previous textbook. We're on here. But matter of fact, you know what? I hope these are the right pages. Yeah, they are. 288 to 295. Anyway, and then that's it. Like usual, let's look at the homework assignment. See what we got. See how many problems we got. Is that it? No. Let's see. We got page 293, 16 A and D only. Give the Excel entry and the result to find T. Use TIMV or T.IMV to find T. The significance is being given to you in one full tail, which will make sense in one tail, which will make sense in a minute. Why I had to say that as a hint. The next problem is from page 293, number 17, A and D only. So there's 2 of them. Give the Excel entry and the result to find T. Don't follow the instructions on the problem. You're just reading it and reading A and doing that one, as this says, giving me the Excel entry using either TIMV or T.IMV. I want to make sure to point this out, by the way. What's weird about this Excel equation, TIMV and T.IMV, it's very different than any other Excel equations, that those are 2 completely different equations, and that you have to enter completely different things in the parentheses for these. So usually, you use like TIMV or T.IMV will do the exact same thing. It doesn't matter which one you use. Last week we used NORM-IMV or NORM.IMV. They did the same thing. You put the same numbers in, but this one is different numbers based on which one you use. So I'm going in a lot of detail on both of these Excel formulas on Thursday. So that's when you want to make sure you figure out which one's easiest for you, because if you start mixing the 2, you're going to have the wrong numbers in the parentheses, because they're completely different. 17A and D is kind of like 16A and D. You're basically finding T. All right? And you're using Excel to find it. Now we go to 19A, A only. Show detailed work solving manually and give the Excel entry to use to find T. I am going to talk about a T table today, just like I talked about a Z table last week. But when it comes to the quiz and the final exam, you're not using the T table. You're giving me the Excel entry to find T. And then you're given the result. Right? So prepare for that. That's why you're also doing it in 19. You're doing it in 16, 17, and 19, all finding T using the Excel equation. But I am going to introduce you to the T table also, so you see what's happening. 25. Show detailed work solving manually and give the Excel entry used to find T. 19A and 25 are both confidence intervals, but you're being given the sample standard deviation instead of the population, because this week is all about that second confidence interval, the one where we know the sample standard deviation, not the population. This is all about T this week. T, T, and T. Right? That's it. You see the homework. What is that? 1, 2, 3, 4, 5, 6 problems, less than last week. Oh, what is going on? This is too easy. All right. Let me know if you need more. All right, so let's get to the stuff. Here we go. We're going to slide. Whoop, hey, hang on. There. Confidence interval for the population standard deviation is unknown. Where do I want to start with this? You know how to recognize it now, right? As soon as you see the sample, that it's the sample standard deviation, you know this is what you have in front of you. And then you're going to use this formula. And the only difference between this formula and the one we used on the homework is that the standard deviation being put there is the sample instead of the population. What do you do? And instead of Z being put here, you're putting T. The hardest part about this week is finding the right T. That's the only hard part about this week. It's finding the correct T. It's tricky with T. It's not like Z. It's tricky. That's all I can say about that right now. Why is it tricky? Well, let me see, do I have a reason why it's tricky in here? Doesn't look like I do. I gotta go to the book. The reason it's tricky is because, matter of fact, let me write this up here before I get this over. Sometimes you have T, oh, I wrote it right here. Sometimes you have T, and then you have the symbol down here for significance, comma, and DF, which stands for degrees of freedom. But sometimes you have this symbol, T, with the little significance symbol divided by 2, meaning half significance, comma, degrees of freedom. DF is degrees of freedom. Now, what is degrees of freedom? That's what this is. Degrees of freedom, here's my big hint. This is really what you should write down. Degrees of freedom is however many are in the sample minus 1. That's the easiest way to know it. But I want to obviously explain to you really where it came from, but for the sake of your first quiz, degrees of freedom is the number in the sample, or the sample size, minus 1. So I got a sample size of 40. What's my degrees of freedom?
39.
You got it. Sample size of 50. What's my degrees of freedom? Okay, good. Now, really what's happening is, let's pretend we have 3 numbers, x1, x2, and x3, and suppose these 3 numbers have a mean of 8. Any number can be chosen for the first number, and any number can be chosen for the second number, but the only way for them to get the mean of 8 is if the third number is an exact number. There's no choice. You can make the first number a 3, make the second number a 10, but the third number now, we have no choice. If the answer has to be the mean of 8, we got to put whatever will make that into the mean of 8. So we were only free to choose the first 2 numbers. The third one we could not. So that's what's called degrees of freedom. Freedom to choose numbers in an equation. If there's 7 numbers in the equation, you have 6, you have freedom, but that 7th number there's no freedom with in order to fit the equation. So it's always however many are in the sample minus 1. So everybody has degrees of freedom. Now let's go back to this formula. So what it's trying to say here, n minus 1 is saying T will be for the degrees of freedom of the number in the sample size minus 1. N minus 1 is the formula for degrees of freedom. But you also have to know which significance. So look at the T table and the T table from the back of the book. Yeah, I want to make sure to show you both of these. T table from the back of the book happens to be on page 729 if you happen to have a book, or let me make this bigger here. The reason I like the T table I posted on Canvas is because it at the top tells you what column to use if you're looking at just one tail significance. The bottom row tells you what column to use if you're looking at 2 tail significance. Now let me make sure you understand what I'm saying by 1 tail and 2 tail significance. Boy, this is gonna be sloppy. There you go. There's our bell curve. Here's our number, our mean or our proportion, whatever. The amount of confidence always represents the center of our bell curve. If I said 90% confidence, let's say it goes to here, we're talking about this is 90% of the area under the curve. This area on the ends is the opposite of 90%, which is the significance. But the deal is, half of it's in one tail, half of it's in the other. So you gotta read the problem carefully to see if it's talking about both of these or if it's talking about one. Because your T table in the back of the book only shows you what the T would be if you're talking about one tail significance. The chart I gave you, I got from the internet, tells you which column to use, whether we're talking about 2 tails or 1 tail. Let's talk about this problem. 90% confidence, 10% significance. I want you to look up 10% significance for degrees of freedom of 9. What's your T? Now, here's the trick. Did I just give you the significance for 1 tail or 2 tails, knowing that I talked about what the confidence is? I gave you the significance for 2 tails because I said 10%. I said 90% confidence, 10% significance. Because I gave you both tails, you gotta go to the two-tail column to the 0.10, and then go down to 9 degrees of freedom. There's your T, 1.833. But be careful. Sometimes the significance being given to you only that's in one tail. And sometimes it's not giving you any significance at all, just the confidence, and you gotta know to use the opposite of the confidence and either use the two-tail or the one-tail. But if you're using it in the back of the book, and I said 90% confidence and I'm not giving you any significance, you gotta know to use the 5% column, because it's 10% significance, and then you gotta divide it in half. In the back of the book, you gotta go to the 5% column. And you can see the middle column, the 5% is right there. That's all you see in the back of the book. You gotta know to split the significance in half and use that column. With this chart, you can say, oh, am I being given both tails? Oh, I'm only being given the confidence? What's the opposite of the confidence? Ready? 95% confidence. Which two-tail column should I use? 95% confidence. Which two-tail column should I use? The 5%, right there. The opposite. You don't, there's hardly any thinking about it. But if you're looking at the back of the book, you gotta say, oh, 95% confidence, 5% significance, divide that in half. Oh, I gotta use the 2.5% column. That's the column heading in the back of the book. This or this on this one. So my suggestion is, if you find it easier to use this one, have this ready to go for the quiz instead of the one in the back of the book. Go ahead.
So on a quiz, would you tell us if it was 1 or 2 tail, or would we have to know by the percent?
You gotta know. If I'm either I'm good to tell you, but odds are I'm only telling you the confidence. You gotta figure out the significance. Let me see. Hang on. Let's read that one. That wasn't one of these a T's. Let's see what's being told here. One of these were a T, I think. Hang on.
Yeah, the last one.
Was it the last one?
Yeah, the last one.
Oh. Yeah. Okay. So let's figure out what this says, and let's figure out which T we should use. According to a survey, high school of girls average 100 text messages daily. Assume that the survey was based on a random sample of 36 high school girls, and the sample standard deviation is 10 text messages per day. Calculate the 99% confidence interval. Okay, let me go here. Wait, what was the sample size? Hang on, I missed it. Hang on, I gotta go back. Okay, what's the sample size? 36. So what's my degrees of freedom? 35. And now, which column should I use? 99% confidence. 99% confidence. Which column should I use? What's the opposite of 99? 0.01. Is that for both tails or one tail? You just told me.
Both tails.
Exactly. So go to the both tails. 0.01. There it is. And how many degrees of freedom? 35. So we got to scroll down to 35. Hang on. Let me scroll down. We know it's the first column though, right? Because we're going to lose that heading. So let me scroll down to 35. 35. Oh. Well, that's why we're using TIMD, I guess. We don't have 35, but we know, well, let's estimate. Estimate what T will be. We know it's between 2.728 and 2.7, is that a 19? Yeah. 19. Yeah, I'm going blind. 2.28 and 19, that's, what is that? That's 9, what's happened 9? Oh, this is gonna be tough, just add 4. So I'm gonna go with 2.723, or 24, right in there. You guys agree? Something like that. You see how to use it though. Go ahead.
So how do you figure out if it's 1 or 2 tails?
Good point. If I'm giving you the confidence, you know the opposite is 2 tails. But if you're looking at the back of the book, you gotta take the extra step and divide by 2, because you're only getting 1 tail at that end.
So if we're given the confidence, then it's 2 tails.
Then you know the opposite is 2 tails.
Okay. So
Right.
then what would a 1 tail situation be?
See, the only time I would only give you a 1 tail significance is on the homework. Let me show you the homework. Oh, did we get this working yet? Hang on. What page was that homework on? No, what is that called? Oh, it is called Cam. What page was that homework? Because I know that there's where you're going to see 1 tail.
Was it like
293?
293?
293, thank you.
Never mind.
That's close. That's close. Here we go. You right? Look at these problems. Hey, what's the deal with the focus here? Hang on. Yeah, somewhere it says autofocus. Oh. Okay. look at right there. Do you see that symbol underneath the T? Can I make that bigger? Hang on. Well, you see the symbol. Okay, look at the symbol for number 2, which is right there. You see that T sub standard deviation symbol divided by 2 comma DF? Now look at the symbol up here. See the T standard deviation comma DF? In number 1, you're being told the significance for one tail. Boy, is that true? Okay, maybe I'm wrong. I think you're being told the significance for one tail. But if you go to number 2, you're being given the confidence, and the opposite would be for 2 tails. So you need to divide it in half. That's the difference between number 1 and number 2. That's the only time you're gonna be given the significance is number 1. I probably would never do that on a quiz, but I want you to see the symbols trying to tell you the significance we're giving you is for 1 tail, not for 2. Do you get it? That's the hardest part about number 1. I heard, you need a question? Yeah, that's it? All right, now let's go to the T chart. Let's look at the back of the book. Look at the headings. Let me scroll out here. Hang on. Look at the top. 0.20, 0.10, 0.05, 0.025, 0.01, 0.005. Those are for 1 tail. So if you're given a problem with only the confidence, the opposite is significance, you got to divide by 2 if you're going to use this table in the back. Because the column is based on how much significance in 1 tail. Again, let's just confirm it. Matter of fact, look at 1%. See how it's 31.821 for 1 degree of freedom? But on the chart, that 1% would be 2% on this one. Let's switch back to this. Instead of 1%, that was 1 degree of freedom, 2%, which is right there. There it is, 31.821, 2%, because this is showing both tails. You'd have to go up there to have the same number from the book, 1%, because there's 1 tail's worth of significance, and this is be 2 tail. This is why I like this one, because whether you are say, oh, I know I gotta divide the significance in half, well, use that top row then as your headings. Oh, I'm gonna use the opposite of the confidence, so use that second row of headings for 2 tails instead. I just find this one easier, but it's up to you which one you wanna use. Go ahead, Chris.
So in a quiz format, is it just preference if you wanna, like, it sounds like.
Well, on the quiz, I'm probably gonna ask you to give me the Excel equation to determine T.
Oh.
I just wanted to show you manually from a T chart, really, this is how we used to do it in the old days before Excel. You don't have to use this, just like you don't have to use the Z chart, but you gotta use it for your homework. No, that's not true. You don't have to use it for your homework. I'm asking for the T equations, aren't I? Yeah, you don't even have to use this for your homework. I'm sorry, go ahead.
We don't have to use this for our homework?
No.
We just said for number 1, we have to use, it's 1, it's asking for.
Number 1, you gotta use TIMD for number 1 on your homework.
Oh, so we're not using the table?
Not even using it.
Oh,
Yes.
so we're not gonna use this on our homework with it. I mean, we're not gonna use the 1 tail for our homework or the quiz.
That's right. So right now she's turned it off. It's turned off because we're not gonna use it. Why even listen to it? All right, so everybody gets it, right? All right. Kind of? That doesn't matter. All right, so let's get to an example. Hang on, let me get to an example. There's the equation again. Everybody remember it? We gotta find the T, the standard deviation's easy, the square root of the sample size. We still gotta use the sample size in the denominator there, square root of it, okay? Matter of fact, let's put this formula up here. What is it? G for whatever, T times standard deviation over the square root of the sample size. This is added and subtracted from the mean. There's the manual equation. Mean plus and minus T times standard deviation over the square root of the sample size. Exact same equation as last week, except there was a Z where the T is. That's the only difference this week. A T's there instead of a Z. Let's go to the first example. Oh, come on, what is this? Well, the example isn't even there? Seriously? I'm giving the whole thing away? A random sample of 25. There's our sample size, 25. Don't forget the pointer in the setup. So right now, that's square root of 25 is that one right there. Has a mean of 50, so I'm putting 50 right there. And a sample standard deviation of 8, so I'm putting an 8 right there. Find a 95% confidence interval. Now for this, just for today, we're using the table. All right? How many degrees of freedom do we have on this problem? I heard it back there.
24.
That's right, 24. Because there's 25 in the sample. Now, we're trying to find what confidence interval? Forgot the percent.
95.
95. So where's the column? 95% confidence, I'm not dividing by 2, I'm not using the back of the book. What's the significance? 5%, 0.05, which is gonna be this column, yes, no?
Yeah.
This column? This column? This is it, 5% is the opposite of 95, this is our column. I'm going down the center one, down to 24 degrees of freedom to get our T. Was it 24?
Yes.
No, 25 is our sample size.
24.
What are you pointing at? Okay, just checking. There you go, I'm going down to 24, there it is. Right at the bottom, we're using the center column, 2.064. 2.064, is that what you got? Let's look at the slide and see if that's what they got here. 2.064, 2.0639, same number. We're using the table. Had we used TIMD, yes, 2.0639, 2.064, same number. All right, we're rounding 3 digits though. They went 4 digits. Now, if this were a quiz problem or a homework, you show me at least 2 detailed calculations. Showing me the square root of 25 equals 5 could be one of them. Taking 8 divided by 5 could be the second one, and then you could jump to the answer and go on. All I'm asking is that you show me details for 2 calculations, from the setup to the answer, 2 calculations in between.
When do we divide by 2?
If you want to use the back of the book chart, you would divide by 2. So for example, let me go to this one real quick. Let's pretend we're using the back of the book. It says 95% confidence. You gotta say, oh, that's 5% significance. Divide by 2 is 2.5%. There's the column you use, 2.5% right there. In the back of the book, all you have is the 2.5%. So you've got to know to divide by 2 if you're using the back of the book. And so you got to use, what, do you remember what the number was? There it is, 2.64. So watch, I'm going to now take this to the book. And I'm going to divide that 5% in half. So I'm going to use the 2.5% column, which is right here, 2.5%. I'm going down to 24. Can we see it? Almost. Hang on. There it is, right there. 2.064. There it is, right above my pointer. 2.064. So you get the same answer. That's when you divide by 2, though, is when you're using the back of the book chart, which is not going to be on a quiz. You're not going to use the back of the book. You're not going to use this one either. But now you know what it's all about. Oh, hang on. So we're getting back here. All right. Let's do another example. Wait, matter of fact, the next example is on page 291. The next example is on page 291. Up at the top. It says, you see that okay? I'm gonna try to zoom in. It says, compute, hang on. Compute, there's that, this is just like the homework. You see that T sub standard deviation, not divided by 2? That means it's giving you the significance for only 1 tail. It's gonna give you the significance for 1 tail. And then degrees of freedom. It says the significance is 0.025 using 2, using 5, and 50 degrees of freedom, come up with each of the T's. All right? Okay, I'm gonna go back and forth. The first one, again, we're using 2.5%, 1 tail, right? 1 tail with what? 2 degrees of freedom. So here we go. One tail, 0.25, right there in the center. How many degrees of freedom? I forgot. 2 degrees of freedom?
No.
There's two.
There's 3 of them, I can't remember. Two is the first one though. 4.303. Is that the first one? Let's take a look. Is the first one? 4.303 right there. The next one, we'd go down to 5 degrees of freedom, we'd find 2.571. The next one, we'd go to 50 and find 2.09. Here's what I want to point out. We stayed in the same column. We used 2.5% significance in one tail. Matter of fact, what was the confidence for this problem? Let's quiz you there. What was the confidence for this problem?
90.
No. No. Yeah. 95%. What she did is she said, oh, if it's 2.5% significance in one tail, that means there's 5% in two tail, which means the confidence has to be the opposite, which is 95%. Very good. So, look what's happening to T as our degrees of freedom keep getting bigger. Our T keeps getting smaller. And if I had taken that all the way to degrees of freedom of infinity, it would be whatever Z is at that point. That's the difference between T and Z. T does not become Z, does not get small enough to be like Z unless you have a huge population, degrees of freedom. A huge, sample, which would be -1 degrees of freedom. So I'm going to scroll down. First of all, at 5% significance, or 2.5% in each tail, if we were looking for the Z, I can tell you what it would be, because it would go to the very bottom of this. 1.96 would be the Z for 95% confidence. Matter of fact, let's go back and look at that chart. 95% confidence. Oh, thank you. 95% confidence is what is the Z? 95% confidence? 1.96. Now let me go back to that table. If the center column, if you took it all the way to a sample size larger than 2,000, a very large sample size, it finally gets you to what Z would be. That's the difference between T and Z. T is a bigger number, which makes the confidence interval wider when you're using sample standard deviation compared to using population standard deviation. If you know the population standard deviation, your 95% interval will be skinnier than if you have the sample standard deviation. The whole point of this confidence intervals is that it's giving you the range of numbers that you can say with confidence, hey, according to this sample, I can tell you that the population mean is between here and here, and I've got 95% confidence of that result. And that here and here, those two numbers, if we have the population standard deviation, we're using Z, it's going to be in here. But if we have the sample standard deviation, we have to use T, our two numbers are out there. That's the only way we can say with 95% confidence our population's in between those numbers. We got to widen it out. So you see the difference between T and Z then. And the difference is we're using a sample standard deviation. So to have that much confidence, we need to widen the range and make the numbers larger. All right, I think we're almost there. Let's go to the next example. I'm going to, how am I doing in time? Doing fine. I'm going on the same page, but I'm going to the bottom. So let me switch this here. In the introductory case of this chapter, blah, 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 Jared Bean wants to estimate the mean miles per gallon for all ultra green cars. Ultra green cars, you know, that was before electric cars. They were like hybrids that were mostly electric, but not completely electric. Ultra green, or maybe electric, you know. The company data file, we didn't open up the file, but I have the information here. Miles per gallon for the sample of 25 cars. There we go, there's the sample size. Use the information, conduct a 90% confidence interval for the population mean. The mean given is 96.52, and let me pull this up. And in the data, the sample standard deviation is 10.697. Help me with the setup. Let me erase these numbers. Help me with the setup. Whoop, whoop, whoop. Okay, what am I putting here for the mean? 96 point, you said 5.2?
Yep.
5.2 plus and minus. T we don't know yet. Standard deviation is what? 10.697. There's our standard deviation. Sample size is how many? 25 cars. And now our T is based on how much confidence? It says 95, 90%, 90% confidence. How many degrees of freedom? 24. 90% confidence is how much significance?
10%.
Two tails is 10%, so look at what column you're using. Oh, shoot. Hang on. 90% confidence is how much significance?
10%.
Come on, what's going on? Oh, I just opened something up. Oh, that's what I'm doing wrong. There we go. Okay, let's say it one more time. 90% confidence is how much significance in both tails? 10%. So here's two tails at 10%. You guys told me there's 25 in the sample size, so the degrees of freedom be 24. So we're about to go down and find our T. I'm going all the way down, the second to the right column to 24, right there, 1.711. Anybody got a book? You confirm that's your, oh, look. Is that what they got in the answer here? 1.71, oh, I gotta go to the next page. 1.711, there it is, 1.711. There it is, and then you do the math. On a quiz, that setup that I just did is where most of the points are on that problem. Showing me two calculation details, there's a bunch of points. Giving me the correct answers, a bunch of points. Giving me the Excel equation to find that T instead of looking it up on the chart, there's some points. I think I covered it. Yeah? No, who had that?
On the last page, you had written on the book what the standard deviation was in the mean.
Yeah, I got it off the file. Well, no, you know what I did? I got it off of the next page is all I did. It says comes with a file, but I didn't open up the file. Instead, I just wrote them on there. Because if this were a problem on the test, I'm giving you the mean and the top of the stand. Well, or else I'm giving you 5 numbers or something where you got calculated, but they're being given to you. Go ahead.
What page was that problem from?
That problem was on page 391 and 392. At the bottom of 391, and then it continued to the top of 392. Here, I want you to just look at the picture of the answer though real quick. So, according to the book, here it is. 96.52 plus or minus 1.711 times 10.697 over the square root of 25. There's the setup, just like we have it. Someone had a hand up.
But you're saying we're not gonna use that chart at all for the.
No,
so-
no. On Thursday, I'm going to show you how to calculate that T using Excel. And that's what you're going to have to use for your homework and your quiz is the Excel equation. But for today, we're just using the chart as if we haven't learned the Excel yet. Good.
Shouldn't you use the column to the left for T? Because
Hang on. What was the confidence? Tell me again.
90%.
What was it?
90%.
90%. Okay, let me switch this table.
'Cause then
So if
you
there's
use-
90% confidence, you tell me how much significance is in both tails
I
together.
think you did the 10% column. Could you scroll up?
Yeah, I will. I want you to answer that question though. What percent of significance is there in both columns
Oh,
together?
5%.
No, both columns. There was 90% confidence, wasn't it?
Yeah.
Yeah, so how much was in both tails together?
Oh, 10% together.
Yes.
Oh, okay.
Now, the opposite of 90% is 10%, that's why we use that column right there.
Oh, never mind. Okay.
Two tails is 10%. Now, if I would said split in half for each tail, then yes, but we're still on the second to the right.
Okay.
You thought it was this one right here, because, I don't know why.
Yeah.
Yes.
For the quiz, it's solving manually.
No, you're solving manually, but for this number, you gotta give me the Excel equation for T. And then the result, which you're learning on Thursday.
Yeah.
Yeah, that's the only difference from today and the quiz, is that you're not looking this up on a T-chart. You're giving me Excel equation. That's the only difference. How do we feel? Here's the one, thank you. You're the only one that feels good. Seriously, is that it? So we want to talk a little bit about life before we leave? Now look, I may have already mentioned this. That's the end of the recording. God, this class is awful.